motors. First of all, I have to explain series motor. Now I will go for motor. Is it visible to all?
No, sir.
And motor. Okay. What is one thing? So previous series motor. Series motor means the field winding is
stop చేసేస్తా రికార్డింగ్ స్టాప్ చేసి రికార్డింగ్ ఆఫ్ చేసి దీనికి 1 minute ఆఫ్ చేస్తే మ్యూట్ లో పెట్టేసి
ఎవరో పిల్లలు మీరు మ్యూట్ ఇది పెట్టండి సార్ సరిపోతుంది నాకు నేను ఇక్కడ చూసాను ఇట్లా కనబడుతుంది.
okay. Previous series motor. Series motor means what? A field winding in series with armature. And it is called series motor. Now I have to go for shunt motor. Shunt motor means the field winding is connected in parallel armature. Then it is called shunt motor. Okay, so this is called armature and petroleum. In parallel with the armature. So it's plus and minus and over. This is represented as V, and the field winding is represented as F. And I have to assume that the current passing or current delivered by the source is represented as I, and it is also considered as I is equal to IL because it is represented as a load current, or had represented as I in some cases, and the current passing through the armature is represented as IA, and the current passing through the field winding is represented as IF, and the armature resistance of the motor is represented as RA, and the field winding resistance is represented as RSH, or in some cases we have to represent it as RF. So supply voltage is considered as V, and armature current is represented as IA, and field current is represented as IF, and current delivered by the source is represented as IL or I. Then I have to represent the equations related to the motor. So here the field winding is connected with armature is known as shunt motor. Similarly, we have to go for shunt generator. The field winding is connected in parallel with the generator. It is called a series generator. So this is common for both motor as well as in generator. Then we have to apply Kirchhoff's voltage law for loop 1. So how to get this one? So we are applying KVL. The sum of voltage risings and droppings in any closed loop is always becomes to 0. Our voltage rising is equal to voltage dropping. So voltage rising is equal to what? V is equal to droppings is what? The voltage drop across armature, that is represented as in the form of a back EMF, EB. So EB, and the drop across armature, the drop in armature resistance. So we have to know that resistance is RA and current passing through this one is represented as IA. So dot drop is represented as the product of IA into RA. And I have to assume that another one, the drop across brushes. So brushes is represented as V. That means brush drop. Or some cases we have represented as this one as brush drop. Directly have represented as brush drop. Now this is considered as a negligible value, is 1 volts or 2 volts. So compare it is very negligible with respect to a 220 volts or 230 volts. So we have to consider this is negligible. Then V is equal to EB plus IA RA. That is the equation number 1. So I have to assume that the first equation, the relation between back EMF and supply voltage. Now I have to modify this diagram as another form, that is called. So one side I have to consider as the supply voltage. Another side, so I have to replace this one as, this is considered as the supply voltage, and I have to assume that this is field winding, because all are connected in parallel. So the voltage across armature, the voltage across field winding is same. So I have to modify this diagram as okay. So this is an armature back EMF, and the armature resistance is RA, and supply voltage is V, and this is RSH, and this is FFM. So I have to modify this diagram for our convenience. So the current delivered by the source is represented as I or IL, and the current passing through the armature is represented as IA, and the current passing through the field winding is represented as I. So this equation, previous is I have to apply KVL for loop 1, we'll get equation 1. So we'll observe here V is equal to the voltage drop across armature is represented as EB, and the resistance produces some drop. That drop is represented as IA into RA, and the drop across brushes is brush drop. So if negligible this one, this is the equation 1. Now I have to go for another side. So I have to apply KVL for loop 2. Here loop 2. So apply KVL means voltage rising is equal to V here, and voltage dropping is equal to what? Only one resistance, that is RSH, and current passing to this one is represented as IF. In some cases, this is also represented as ISH. Because of field winding, current is represented as ISH, and resistance is represented as RSH. So that is equal to IF into RSH. So IF is equal to V by RSH. That is the equation number 2. So I will get the first equation is V, and second equation is IF. And by observing this one, here IL is equal to the sum of current centering to the point is equal to sum of leaving to the current. So and so I is equal to from I is equal to IA plus or IF is equal to I minus IA or IL minus IA. That is the equation number 3. So suppose if you want to find out IA is equal to what here? I minus IF.
Ramesh sir. Sir, Ramesh sir. Sir,
సార్ చెప్పండి సార్.
we are unable to see the equation, sir. I is equal to IA plus IF. అది ఆ లైన్ ని మార్జిన్ పెట్టుకోండి సార్.
ఓకే
ఆ లైన్ ని మార్జిన్ పెట్టుకోండి.
ఓకే 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 ఓకే.
దాని కింద మనకు కనబడటం లేదు సార్.
ఓకే, నేను మారుస్తాను సార్. ఓకే, థ్యాంక్ యూ.
Okay, then from equations I is equal to IA plus IF, we'll apply this one. What is the equation here? Either IA is equal to I minus IF, or IL minus I. So from equation 1 and equation 2, and this is considered as equation number 3. We will get the voltage and current equations of DC shunt motor. So first I had explained briefly. First we have to assume that what is the shunt motor? The field winding is connected in parallel with the armature is known as a shunt motor, and the current delivered by the source is considered as I. The current passing through the armature is represented as IA. The current passing through the field winding is represented as IF. Then apply KVL in loop 1, or replace this diagram as this one, and apply KVL in loop 1. I will get the equation number 1, and apply in loop 2. I will get another equation, that is IF is equal to V by RSH. And from these equations, we have to apply KCL at node 1 or at node A. I is equal to IA plus IF, or I is equal to I minus IF, or IL minus IF. So this is the voltage and current equations for shunt motor. Suppose if you want to modify this motor equations for generator, okay, how to modify that? Simple modification is, so we are well known about generator, even though I had to explain generator equation modifying this one. Okay, how to modify that? Suppose I have to go for, this is a shunt generator. Okay, shunt generator. So here I have to modify this one as a load. This one as a load that is considered as V. Okay, and I have to modify this EB is nothing but a generation. So here we have to modify this one as EC, and this is considered as a resistance RA. R for convenience, we have to assume that this is easy, and this is easy. So all of you mute. You're getting noise. So same equation here. We have to replace.
Yeah, my letter.
హలో,
చెప్పాలి కదా ఫోన్ చేసి.
హలో.
Okay, here we have to modify this one. So the equation, supply voltage.
థర్డ్ ఇయర్ వాళ్ళు బాగానే వస్తారు సార్.
This is the supply voltage.
ఫైనల్ ఇయర్ వాళ్ళు బెంచ్ ఒకరిని కూర్చోబెట్టాము.
Sir,
దాంట్లో 15, దీంట్లో 15 చెప్పారు.
సార్.
Okay, we have to modify this one. What is the equation? I will explain just one equation. Here, this is delivered current. This is delivered current is represented as IA, and the current passing through the load is represented as IL, and current passing through the field winding is represented as IF. So here we have to apply KVL for loop 1 as well as the loop 2. So apply KVL in this loop. EG is equal to what here? There is some drop is there. Supply voltage is equal to droppings. Or apply KVL in loop 2. First we will go for loop 2. Then I will come for loop 1. Apply KVL for loop 1, loop 2. EG is equal to V. Because of this is the drop. Drop is always opposed as the supply voltage or supply, that is V, plus the drop across armature, that is called IA, RA, and here the brush drop, VD. So previous, we'll observe the equation. What is the previous equation? You know that E is equal to EB plus IARA plus BD. Here EG is equal to V plus IARA plus BD. If you are negligible this one, that is BD is negligible, means the equation is EG is equal to V plus IARA. Here this equation is modified as so our generator EG is equal to V plus IARA, and we are applying KVL for loop 1. What is the value? EG is equal to, we'll apply, this is IARA plus this is IF into RSH plus B. So if I negligible this one and negligible this one, then IF is equal to EG by RSH. So same as the previous one, small modification for DC generator and DC motor. So we are well known about DC generator equations in previous classes. I know that this is the unit 2. So I will go for only motors. So this is DC generator, previous I have come DC motor. And same here IA is equal to, apply KCL at point this one. IA is equal to IL plus I. Previous is IL minus IF, and here is IL plus IF. So that is the equation number 3, and it is equation number 2, and it is equation number 1. So that is called a series generator and series motor. Now we go for a compound motor. Now go for compound motor. So what is meant by compound motor? A motor which consists of both series field winding as well as shunt field winding, that is called a compound motor. Depends upon the field winding connected to the armature. The compound motors are divided into 2 types. First one is long shunt compound motor, and second one is short shunt compound motor. So a motor which consists of compound means nothing but a combination of series and shunt. So the motor consists of both series field winding and shunt field winding. Then the motor is called a compound motor. So depends upon the field winding connected to the armature. The motors are divided into two categories. First one is a long shunt compound motor. Second one is short shunt compound motor. Now I have to go for long shunt compound motor. So what is meant by long shunt compound motor? The name itself defines. The name itself defines long shunt, long. So shunt field winding is connected long after series. So I will explain what is meant by long shunt compound motor. Okay. Now go for long shunt compound motor. So long shunt. So field winding. So first one we have to assume that the armature. Long means after series. You should remember a simple. First we connected a series winding. Then after that we have to connect a shunt field winding across to the armature. Then it is called a long shunt compound motor. Now I have to assume that this is a supply voltage that is represented as plus minus B. So this is considered as a motor having back EMF EB and armature resistance is represented as RA. And this is a series field resistance and this is a shunt field resistance, and the current delivered by the source is represented as I or IL, and this is considered as a node 1. The current passing to the field winding is same as the previous one, and current passing through the armature is represented as IA, and current passing through the series field winding is represented as ISC. So this is considered as a loop 1, and this is considered as loop 2. Another one is same as the previous one. Previous I have modified that. So we have to go for the modification also, same as the previous one. This is one side is series field winding and the supply. Another one is a shunt field winding. So same as the previous one. So the back EMF of motor is EB. The armature resistance is RA, and this is considered as RSC. The current passing through this one is represented as ISC, and the current delivered by the source is represented as IL, and supply voltage is V, and the current passing through the armature is represented as RA, and RA is equal to same as ISC because of the current passing through the series field winding and armature is same. So IA is equal to ISC, and the current passing to the field winding is represented as IF. So F. So this is a compound motor. Just I have to modify a compound motor like this one for convenience of equations. We have to modify this one or that one. Both are same. So long shunt. What is long shunt means what? First you will observe here, series field winding is connected before shunt field winding. So long. So after series field winding, we are connecting shunt field winding. So it is called a long shunt compound motor. So what the definition is? The shunt field winding is connected in parallel with the armature and series field winding. And the shunt field winding is connected in parallel with the armature and series field winding is known as long shunt compound motor. What is the previous one? The shunt field winding is connected in parallel with the armature only. It is known as shunt motor. So in parallel with the armature as well as series field winding, it is known as a long shunt compound motor. Now I have to consider this is a loop 1 and this is considered as a loop 2. So we'll go for that voltage equations for loop 1 and loop 2. So first of all, I'll go for the loop 1. What is the loop 1 equations? So we'll observe, apply KVL in loop 1. V is equal to, because of it is voltage rising, what is the drop in here? EB. We'll observe this one. And another drop is due to the armature resistance. So plus IA RA. And another drop is due to the series field winding, that is called ISC into RSC. And another drop is the brush drop BD. So for convenience, I have represented as BD. And this is negligible if BD, that means bus drop is negligible. Then what is the value? V is equal to EB plus IA RA plus ISC into RS. Suppose here we observe IA is equal to ISC because of the current passing to the series field winding as well as armature is same. So if RA is equal to RAC. So if IA is equal to IS, then V is equal to EB plus IA RA plus IA RS. Okay, then we'll come to this point. R V is equal to EB plus IA common, then IA into RA plus, that is the equation number 1. So V is equal to EB plus IA into RA plus RSC. That is the equation number 1. Now we'll go for loop 2. Okay, so apply KVL in loop 2. Okay, apply KVL in loop 2. What is the here? Voltage dropping. Voltage dropping is equal to the drop across shunt field winding. And what is the voltage rising here? Supply voltage. So V is equal to IF into RSH. R IF is equal to, so this is considered as equation number 2. RIF is equal to V by RSH. That is the equation. So by equate these equations, so V is equal to IF plus RSH Or if you want to find out IF is equal to V by RS. This is the equation number 3. Now apply KCL at loop 1. Apply KCL at node 1. IL is equal to IA plus IF. Sum of voltage entering is equal to sum of voltage leaving to the point. So voltage entering to the point is equal to IL is equal to voltage leaving IA plus IF. So that is the equation number. So if you want to go for long shunt compound motor, the previous equations and this equations is approximately same, except in this equation V is equal to EB plus IA into RA plus RS. Here we have replaced IA into RA. You will get the previous equations. Remaining all equations are same. So long shunt compound motor and long shunt compound motor equations is approximately similar. Suppose if you want to go for the generator. Generator means we are well known about previous one. We have to modify them for generators. Okay, this is for long shunt compound motor. Now I'll go for a short shunt compound motor. Now, what is meant by short shunt compound motor? Here. What is meant by short shunt compound motor? So short shunt, the name itself defines short shunt. Short shunt means the shunt field winding connected short. That means before series field winding. Okay, before series field winding. So the field winding is connected across this like this. So that is called a short shunt compound motor. Okay, now you consider this is the loop 1 and loop 2 equation, same as this one. So previous one is short shunt compound motor. Now it is short shunt compound motor. Short shunt compound motor means the field winding, the shunt field winding connected across armature only. That is called a short shunt compound motor. So short means shunt field winding is sharply connected to the shunt motor. So RSH, then I have to assume that the current passing to the field winding is represented as IA, and the current delivered by the source is same, and the current passing, this is same, and current passing through the motor is represented as I. Then I have to consider that this is the loop 1. I have to modify this one for our convenience. What is the modification? One side I have to replace this one. Middle we have to represent it as apply voltage. And one of this one. So here you will observe one side is connected to the series field winding and back EMF. So one side series field winding, So you'll observe here in loop 1, V and IARA and ISC. So first I will explain this one. Then if there is have any doubt, I will explain modification of another diagram. So we are applying KVL for loop 1. V is equal to this one. What is the value? ISC into RSC. ISC into RSC. Plus here the drop across armature EB and IARA and brush. Same as the previous one, if BD is negligible. Okay, BD is very less or negligible value. Then what is BD is very less, negligible value. Then V is equal to, I have to modify this one, EB plus IARA plus ISC into RSC. Here ISC, the current passing the series field winding and supply voltage is supply delivered current is same. So here IL is equal to IS. So if IL is equal to IS, then what is the equation? V is equal to EV plus IA RA plus IL RS. Okay, I will consider this is the equation number 1. Okay, now to go for another equation, another loop. Another loop means I have to explain for convenience. This is simple. So we are applying only outer loop. Outer loop. So that is the case in loop 2. So apply KVL in loop 2. Apply KVL in V is equal to ISC into RSC. V is equal to ISC into RSC plus this one, IF into RSH. IF into RHS. There is no other equation here. V ISC into RSC and IF into RSH. Okay, here ISC is equal to IL or V is equal to IL into RSC plus IF into RSH. That is the equation number 2. So the voltage equations, one equation and another equation. Now we will go for KCL at node 1. So apply KCL at node 1. What is the equation here? Sum of currents entering to the node is equal to IL. So IL is equal to sum of currents leaving to that node, IA plus I. IA plus, that is the equation number 3. Okay, so for convenience, I have to modify, redraw this diagram. Let's have any doubt, I will modify this diagram as. So one side is supply voltage. We'll observe here, and middle we have to consider as supply voltage. And one side is series field winding as well as the motor. Together, series field winding and motor, that is EB, and this is RSC, and current delivered by the source. Here, this is supply voltage V. We'll observe this one, series field winding. So this is RFC. And current delivered by the source is equal to IL. And current passing through the series field winding is ISC. And current passing through the armature is represented as IA. And same, in another part, we'll consider as this is the RSC and field winding. Here is the field winding, that is called RSH, and this is ISH and F. So first equation, this is considered as a loop 1 and this is considered as a loop 2. Loop 1 and loop 2. So we'll observe here, apply KVL in loop 1. What is the equation you get? V is equal to the drop of ISC into RSC. So ISC into RSC plus the drop of motor IA. And here the armature resistance is there, RA. So IA into RA plus BD. If BD is negligible, then this is negligible means V is equal to, I have to modify this equation as EB plus IARA plus ISC into RSC. And you will observe here, the current delivered by the source and current passing the series field winding are both are same. So IL is equal to ISC. Then this is equal to, V is equal to EB plus IARA plus IL into RS. That is the equation number 1. Now apply KVL in loop 2. We'll observe this one. V is equal to the drop across series field winding, that is equal to ISC into RSC, and plus the drop across shunt field winding, that is equal to IF into RSH. Then V is equal to IL plus, suppose I have replaced ISC as IL because of the current passing the series field winding and delivered source is same. So IL is equal to ISC. So modify this one. V is equal to IL RSC plus IF into RSH. Then apply KCL at node 1. You will get the equation 2. Then apply KCL at node 1. The sum of currents entering to the node is equal to sum of currents leaving to that node. So IL is equal to IA plus IL. So this is a long short shunt compound motor. So first of all, we have to take the snapshot for this one because for convenience, this is the sufficient equations for short shunt. So all of you take the snapshot for short shunt. Similarly, for each and everything, once the top I had to explain, just take the snapshot, then you will get an idea about each and everything. Okay, so today I had to explain a short shunt compound motor as well as long shunt compound motor and shunt motor. Okay, then If you want to go for shunt generator or compound generator, same equations, small modifications. We are alone about the previous one. So I will stop today class. So all of you take the snapshot up to this point. Next class I will continue the problems related to short shunt, long shunt and compound motor as well as in series motor. Next I will go for the remaining problems. I will come.